Hokie dokie, welcome to this week's quick quiz lesson. In this video, we'll be covering some of the big ideas in 1524's quiz 13 in 15 minutes or less. Let's get started.
Before we get into it, if you have not yet watched this intro to partial derivatives, I highly recommend it first. Now back to the video. In this problem, they say let R of FP represent the revenue in dollars when the company produces F frames and P prints. Then they say interpret RP 6235 equals 49. So the first thing to recognize is RP. That's the revenue's derivative with respect to the prints. So in other words, the marginal revenue with respect to prints. So right away, we want to look at the end of each statement and we want to make sure it says for each additional print produced. So anywhere they say frame, we can eliminate those options. So now if RP represents the marginal revenue, they're telling us that RP equals 49. So what this means is the marginal revenue is 49. And keep in mind what marginal revenue means. It means the revenue will go up by 49 if you produce one more quantity. In this case, we're talking quantity of prints. So the revenue will increase by 49 for each additional print produced. And that is option B. To address choice D, keep in mind the marginal revenue is 49, but the marginal revenue is not increasing by 49. So yeah. Let's do one more real quick. We see CW. C represents cost and W represents wetsuits. And so CW is the partial derivative of cost with respect to W. In other words, the marginal cost with respect to wetsuits. So at the end of the statement, we should see the word wetsuit produced. We can eliminate A. And then because CW is equal to 17, that's telling us the cost should be increasing by 17 per wetsuit. And that's what option B says. And we're done. Maxes, mins, and saddle points. So last week when we dealt with certain contour plots, we learned that the lighter shades in the contour plots represented the larger function values. And so in this problem, we are given a contour plot with these light, dark, and sort of like medium gray shades, and each of those different colors sort of represent different extrema, if you will. So the lighter the shade, the larger the function value. So points like option D and then all these other lighter shades represent maximums because they are the larger or greater function values. And then the darker points on the graph, for example, C and all those other red stars, those represent the minimums because they are the darkest points on the contour plot, which means they are the lowest points of the function. And then in addition to maxes and mins, we actually have these in-between values like A and B that are known as saddle points. So saddle points are kind of like this in-between area where you have surrounding maxes and mins. And in sort of a 3D context, you could probably see saddle points in some of the functions that we dealt with last week that you had to graph in Excel, like this one here. So with all that in mind, number 2 is the only correct answer. So G is our answer here, and we're done. And in this problem, they give us this chart. They give us X values across the top, Y values across the side, and then all the intersecting function values that those X and Y values produced. And then they give us these 3 statements asking about maxes and mins. And so I'll just start us off with number 1. They say F does not have a relative min at negative 0.5, 2.5. So what we do is go to negative 0.5 on the X, 2.5 on the Y, and find where these two intersect. So they intersect at negative 16. And for it to be a relative min, we would want to check, is negative 16 the smallest value relative to all the values that surround it? And if it is, it will be a relative minimum. If negative 16 is not the smallest relative to the surrounding points, then it will not be a relative min. And so we can definitely see a few values next to negative 16 that are much larger than it. And so to say that F does not have a relative min at that point is true. So then number 2, they say F has a relative max at negative 0.5, 2.5. So I guess we're still looking at the same point here, the negative 16. So in order for it to be a relative max, negative 16 would have to be greater than all its surrounding values. But again, we also see values that are greater than negative 16. Therefore, negative 16 is not a relative max either. Therefore, F does not have a relative max at negative 0.5, 2.5 either because the negative 16 is not the largest. And so because this statement says it does have a max, this statement is false. Number 3, they say F has a saddle point at 3.5 comma negative 0.5. So these values intersect at this 0 here. And how we identify a saddle point is this. We can see this diagonal of zeros across this table. And if the location they send us to lies on a 0 that lies on that diagonal of 0, zeros, then we have found our saddle point. So in fact, they could have sent us here, 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 any of those zeros, and those are all locations of the saddle. The saddle point lies on all these zeros here. And so in this case, F does have a saddle point at that location, so that is a true statement. 1 and 3 are correct, so H is our answer, and we're done.
Chain rule, product rule, and quotient rule with partial derivatives.
In this problem, they tell us to find Fy. If this is f, this function has two layers, the outside layer being ln of something, and the inside layer being x to the 7th y squared z plus 5z. We have to use the chain rule for this one because there are two layers. We take the derivative of ln of something, and we get 1 over that something. So originally, if we had this in the parentheses, we want to throw all that same stuff in the denominator when we take the derivative. So that's the derivative of the outside layer. Now let's find the derivative of the inside layer with respect to y, because we're looking for Fy. So what we do, we identify the y term, that's just y squared. We take the derivative of that and we get 2y, but any terms that were attached to it will stay attached to it. So we have x to the 7th times 2y times z, and then because we're taking the derivative with respect to y, any term that does not have y will have a derivative of 0 because it's treated as a constant. And so this is our derivative of the inside. So now just multiplying these two terms, we get this. And the only thing they might do is move this 2 to the front. So they might call it 2x to the 7th y z all over x to the 7th y squared z plus 5z. And that's option A. And we're done. And in this problem, they give us this function that looks crazy. They tell us to find df dy, the first derivative with respect to y, and then at this ordered pair, -5, 3. And so what we want to do first is find the partial derivative with respect to y. Then we will plug in x equals -5, y equals 3. To find the derivative of this function, it will take kind of splitting it up into two pieces. The first piece is 5x squared y. The second piece is e to the x plus y. What we have is two different y terms being multiplied together. So what we need to use is the product rule. And so we learned previously that product rule is always a prime times b plus a times b prime, if a is our first expression and b is our second. So now in this case, because we're finding Fy or df over dy, each derivative we find will actually be with respect to y. So when we take the derivative of a, we will take it with respect to y, and then same thing with b. And so starting off with a prime, the derivative of 5x squared y. The derivative of that with respect to y is 5x squared times 1 because the y term has a derivative of 1 and then the 5x squared was originally attached to that y, and so now it stays attached to the 1. Our b term is just the original e to the x plus y. Our a term is just 5x squared y, and now by is the derivative of b with respect to y. So now e to the something has a derivative of e to that same exact something, so e to the x plus y. And now if need be, we might have to use chain rule here, but chain rule just says we would need to multiply by the derivative of the inside layer, which is just x plus y. Now, the derivative of x plus y with respect to y, the x term is treated as a constant, so it just goes to 0, but when we take the derivative of the y term, it's just 1. So we have 0 plus 1, or just 1. So if anything, we multiply the e term by 1, but that will not change anything here. So for by, we just have e to the x plus y. So now we have successfully found Fy, or df over dy. So now all we do is plug in -5 for x and 3 for y wherever we see those terms in the mix. And so when we set that up, it looks a little something like this. And once we calculate it, we get about 67.67 or 67.7. That's option C, and we're done. So in this problem, they give us this function of x and y, and they ask us to find the derivative with respect to y and then plug in 3 and -4. Just make sure when you find a prime and b prime that you're finding those derivatives with respect to y. So when we plug in x and y, it looks something like that. And once we calculate it, we get about -23.03. And that's option D, and we're done. In this problem, they ask us to find d squared g over dx squared. What that means is we need to first find the derivative of g with respect to x, or gx. Then we'll find the derivative of that with respect to x again. So it's the second derivative, both with respect to x. Starting with 4x to the 4th, we get 16x cubed. And if we took the derivative of that, we'd get 48x squared. And frankly, there's only one answer with 48x squared. So A must be our answer. Let's go a little bit more in depth. On to the second term here, 7y cubed over x cubed. We could think about it like this. To get a derivative like this, And then one more time to get this, while that 7y cubed remains the same the entire time. Now on to this term. We use chain rule to get the derivative of the 4 power. Then we multiply by the derivative of the inside. And then we leave the ln of 4y because it was attached to the x term at the start. And then one more derivative of the outside layer times one more derivative of the inside layer. And the ln of 4y remains unchanged. So now 7 times 12 is 84. We have y cubed. If we have x to the negative 5, we can throw it in the denominator as x to the positive 5. 12 times 9.
96? No, 108.
12 times 9 is 108. And we leave the rest. And that's it. And we're done. In this problem, they say find gxy. So we'll find gx first, then find the derivative of that with respect to y. So 7x squared goes to 14x. Y squared is a constant, so we leave it on the bottom. The derivative of e to the something is e to the something, but then we multiply by the derivative of the inside, which is 5. Likewise, we leave all of that over y. 5 over x is 5x to the negative 1, which has negative 5x to the negative 2 as its derivative. If we rewrite that, we have negative 5 over x squared. Now the derivative of this with respect to y. This first term is really this. The derivative of the y term is this. We leave the 14x. The second term is really this. That's the derivative of the y term. The rest stays unchanged. And this third term has no y's in it, so the derivative with respect to y is 0. 14 times negative 2 is negative 28. We leave the x. We throw the y cubed in the denominator. This negative times 5 is negative 5. We leave the e term, and then we throw the y squared in the denominator. And b is our answer. And we're done. Now, with having just learned all these partial derivatives, these are very challenging problems if you're trying to find all the derivatives of every single term like we just did. So what I recommend is this. Take the derivative of just one term as confidently as you can all the way through, because if you do, all these terms in the answer choices are distinct enough usually that you can identify the answer just from one of the terms that you've taken the derivatives of. So for example, if we just followed the first term all the way down and we got this negative 28x over y cubed, that's the only negative 28x over y cubed in all of the answer choices. And so if you can successfully take the derivative of one of the terms, you'll be in good hands. Kind of like we saw in this last problem where we had 4x to the fourth, we just took two derivatives of that with respect to x, and we got that 48x squared, which only showed up in option A. And for this last problem, I'll let you try it out on your own, but I'll give you the steps to walk you through it. We are given a function cost in terms of x and y, where x represents the number of junior programmers and y represents the number of senior programmers. They say use marginal cost to determine which of the following options is most cost effective if 17 junior and 9 senior programmers are currently employed. So the approach is this. First, you will find cx, the partial derivative of cost with respect to x, because what this represents is the marginal cost with respect to junior programmers. And then you will find cy, the derivative of cost with respect to y, because this represents the marginal cost with respect to senior programmers. And then what you'll do is plug in the given x and y values to both cx and cy. The given x value is 17, the given y value is 9. And once you calculate cx and cy at those given x and y values, the more negative of the two values will tell you who to hire. What do I mean by this? Let's say, for example, CX equals 120. What this means is that the marginal cost associated with hiring junior programmers is $120, meaning if you hire one more junior programmer, it's going to increase the company's cost by $120. And that's not good. That's not cost effective because it's going to cost the company that much if they hire one more junior programmer. But let's say when you plug in the X and Y values, you find that CX is negative 200. This is cost effective because what this means is if you hire one more junior programmer, it's going to lower the cost by $200, and that's really good. However, if you find that CY is negative 300, then what that says is if you hire one more senior programmer, then that will actually lower the cost by $300 for the company. And that is even more cost effective because it's a more negative value. So that's what I mean by the more negative value will tell you who to hire, because if we have the more negative number, that's that's going to make the company's costs go down more, which means it'll be more cost effective to hire a senior programmer. So if the answer is hire one more junior programmer, what that means is that CX was the more negative value. If the answer is hire one more senior programmer, then CY was the more negative value. If when you plugged in your X and Y values and you got both positive values for CX and CY, that would mean it's not cost effective to hire anyone, because hiring either person will make the cost go up regardless, which is not cost effective. And then in the case that they don't actually give us any X and Y values to plug in, that means the answer will be there's not enough information provided, and we'd be done. So give this problem a shot. If you have any questions, keep in mind I have a full video working out this exact problem, but if you want to check your answer right now, C should be your answer.
Alrighty, if you enjoyed this video, go ahead and hit the like button. If you want to stay updated for the last quick quiz lesson of the semester, go ahead and subscribe. If you want to connect with me or other students in the same course as you, or ask me questions or anything else, join the Discord. That's all for this week's quick quiz lesson. I hope you learned something. I'll see you next time. Bye-bye.